Welcome all to the channel where we make statistics simple and easy for everyone. So today we are going to learn about logistics regression in SPSS. Logistics regression is whereby we have two outcomes. The dependent variable has two outcomes or it's binomial. In this case, we are trying to predict churning, customer churning from banks or ending the relationship with the banks due to one reason or another. So the things that we can say that are can predict this. We have some various predictors, that is credit score. We have gender. We have age. We have tenor. We have balance, that is the current bank balance. That is, and then we have the credit card, whether it's a yes or a no, whether they have or don't. And then again, we have an active member, the estimated salary. So what you need to do is go to analyze regression. And then here at regression, we have all these types of regression. So we are talking about binary logistics. So our dependent variable, as I indicated, was to churn. And then now our covariates or our independent variables were from credit score all the way down. So the other thing we need to identify is which are categorical variables. So we have gender as a categorical variable. We have credit card, and also we have active membership. And then the other thing, we just click continue. And then one of the things that I like to use is to measure the goodness of fit of this model. So we tend to use the HOSMA, let me show goodness of fit test. So just click OK. And then you say continue. And just click OK. And here we have our results. So when we have our results here, of course, we had 10,000 entries. So, and we had no missing cases. So the main thing that I would like us to help us in interpreting our results. So these are our categorical variables. So let's go to, you see we have step 0. Let's go to step 1 where we've incorporated all the variables in the equation. You see in step 1 we only have the model itself predicting by itself. So but we go to, that is where we have step 1. So in step 1, we have the chi-square, that is step, and the block and the model, whereby it tells us that this model is adequate in explaining. So adequate in explaining the variation in churning. So the other thing that is really important here that I had already indicated to you is about the HOSMA and Lemichaud test. The HOSMA and Lemichaud test is a very interesting test because in this test, the null hypothesis says that the model is sufficient in explaining the variation in the dependent variable, that is explaining the outcome or explaining the churning in this customer in our case. So if the p-value is lower than 0.05, we reject the null hypothesis. And what is our alternative? That the model is not adequate. But in this case, you can see the p-value is higher than 0.05. So we fail to reject the null hypothesis, which indicates that the model is sufficient and adequate in explaining the variation in the dependent variable. So it tells us here 0.587 is higher than 0.05. So which tells us our model is good. The other thing, the model summary here, we have the Cox and Snell R squared, and also the Nagel-Kaci R square. So the Nagel-Kaci and the Cox and Snell R square, these are just proxies of the normal R square that we use in the other regression, like the multiple regression, the linear regression. So in this case, it tells us here it is 0.206. That is 20.6% of the variation of the dependent variable is explained by this model. So that is what it tells about the model summary. So the other interesting table here is the classification, whereby this is the major part here, whereby it tells us that overall this model is able to explain 80%, 80.8% of the variation. So the overall percentage is very high, which tells us that our model is very good and it's accurate in explaining this dependent variable. So let us go to our our variables or our predictor variables. So one of the things that about these predictor variables is that we have the beta values here. Remember that these beta values are in terms, if for you to be able to interpret them well, you have to exponent them so that you can give you in terms of odds. Remember, we interpret our logistics regression in terms of odds. We have 5 odds, 10 odds, or higher than the other one. So that is how we do it. So, and in our case here, the last column has already been interpreted for us in terms of odds, so that it tells you that exponential b, that is exponential beta. So, but first thing first most, we usually check on our significance. So when we go to check on our significance, we can see that tenor here is 0.11, so it is not significant. So the number of years you are in a bank does not determine. So the other thing is credit card. Either having a credit card or not does not determine whether you're going to churn your relationship between the customer, between the bank. That one does not. And also estimated salary does not impact. So let us try to interpret one of the variables here. For example, let us interpret gender. So you can see gender here, the beta was 0.542. So what is the exponential of it? That is 1.719. So in our case here, we had started 1 representing male. So we can say that the males have 1.719 odds higher than the female to churn the bank. So that is what it explains here. So if you go to something like let's say, for example, even active membership, that is 1.0, and then what is its exponential? That is 1.2, that is 2 point. So you can say that active membership has let's say here we had said one, no membership, and then the other one was with membership. So we can say that somebody who has membership, active membership in this bank has 2.9 chance of churning the relationship with the bank compared to the person who doesn't have or has 2.9 odds or chances higher of churning that relationship compared to the other person. So generally, that's how you interpret your logistics regression model. Thank you so much, and remember to subscribe.